Today we shall have a look at the XOR classification problem. Now what is the meaning of XOR classification problem? We know the truth table of an XOR gate. If at all we have an XOR input, we consider an XOR gate with input x1 and x2 and the expected output. So if at all the inputs are 0, 0, 0, 1, 1, 0, 1, 1, the expected output will be 0, 1, 1, 0. So now the problem, when we calculate net, so that we can do this problem, if at all we calculate net, by selecting say positive weights. So if W1 and W2 is equal to 1, then what happens is that net value, which is equal to x1 plus x2, will be 0, 1, 1, 2. So what happens is that this particular problem, if at all I implement it, I show it to you on the x1, x2 plane. This is x1 and this is x2. So this is like two classes are present. This 0 belongs to class 1 and the 1 output belongs to class 2. So this two class classification problem, basically AND gate, OR gate, all of these are two class classification problems and which can be solved by using a single neuron. But in this case what happens is that I will be, when I plot this particular points, say for example at 0, 0 the output is 0 and the output is 0 again at 1, 1. So here at 1, 1 the output is 0. So these points are nothing but this is 0, this is 1, this is 1. So what are the other points? The other points are here. 0, this is 1, 0 and this is 0, 1. So basically X stands for class 2 and O or 0 stands for class 1. Now from the previous thing, we already know that whenever we have a single neuron corresponds to a line. A single neuron corresponds to a line. And if at all we want to separate, it is not possible to have one line separating these two classes. Say if at all I select a line somewhere here. If at all I select a line somewhere here, is it going to separate the two classes? Is it going to separate the two classes? No. If at all I move on the line somewhere here, is it separating the two classes? No. So how would I draw a line? If at all I rotate this particular line in some different direction, is it separating? No. So I am just trying to rotate this particular line in such a way that it separates? No. So now also it doesn't separate, because what happens is that at any time what you can see is that 3 points are on one side and 1 point is on the other side, or in this case maybe something like this. If at all I do, 2 points are on one side but both of them are of two different classes, so you cannot separate. So if at all it was a simple OR gate, if at all it was a simple OR gate, then maybe it was possible to do this. If at all it was a simple OR gate, what is the OR gate? OR gate has got 0 output for 0, 0 and rest of the times the output is 1. So here it is 1. So for an OR gate, it is possible to have a line such that it separates. Yes. So here I have drawn a line such that all the x's are on one side of the line and all the zeros are on one side of the line. So you can draw a line which separates this line, yellow line which is there, it separates the patterns into class 1 and class 2. So this is OR gate. So OR gate problem can be solved by using a single neuron. So we have the OR gate problem which can be solved by using a single neuron. AND gate, so OR gate problem can be solved is your OR gate problem is solved using a single neuron. Using single neuron. Or I can say that OR classifier can be designed using a single neuron. But we have seen that the XOR gate problem or the XOR classifier cannot be solved, or XOR classifier cannot be designed using a single neuron. So I am going to ask you that this is what is the background idea I have given you. So the XOR problem cannot be solved using a single neuron. So how we will be solving this particular problem? How? Maybe we draw one line here and we draw another line here, and I say that whatever is in this side of the line and on this side of the second line is belonging to class 1, and whatever is in between these two lines belongs to class 2. So one line corresponds to one neuron. So I have to use two neurons here, but that is not going to be the only option. That is not the only thing. There are two regions, there are three regions which come into picture. So again one more neuron will be required. So that we shall see. But the point here which you all need to keep in your mind is that XOR classifier problem or XOR classification problem cannot be solved by a single threshold neuron. Why I am calling it a threshold neuron? Because it is a TLU which we are using here, or a signal function. So whatever is on one side of this line belongs to one class, whatever is on the other class of that line belongs to another class. So we shall now have a look, we shall now prove how single neuron cannot solve the XOR classification problem. So first thing what we will be doing is that why it is not possible for a single neuron to solve. Secondly, how to solve this XOR classification problem. Is that clear? So first we shall see how to prove that no single threshold neuron or perceptron So prove that no single threshold neuron or perceptron can solve the XOR classification problem. So now we have the truth table which is given and the expected output which is given, and this side we have shown the x1 x2 plane. So this is the x1 x2 plane which is shown, and these are the 4 points which are shown, 2 belonging to class 1, 2 belonging to class 2. Now we will be just assuming and we will be calculating the net value for this. Now what is the net value for this? Net value, since for a single neuron, will be x1 w1 plus x2 w2 plus we will be considering the bias, that is your net plus bias. So if I tell you what, I can write this particular net, assuming that w1 and w2, I am going to assume that okay, let's not assume anything. So we shall be calculating the value of net. So what is the value of net that we will get? So in first case x1 and x2 is 0. So first case what I will get is that I will get 0 plus bias. Second case I will be getting x1 is 0. So x1 is 0 meaning this term will go and it will be x2 will be 1. So I will be getting w2 plus bias. Third case what I will get is, x2 is equal to 0. So this term will go. So I will get w1 plus bias. And the last case both are present, x1 as well as x2 is present. So I will get w1 plus W2 plus bias. So this will be the net calculation. Now in the first case what you can see is that the expected output has to be 0. So when we need the expected output to be equal to 0, the net value has to be less than 0. And in this case also it has to be expected output is 0, so it should be less than 0. Whereas in these two cases expected output is 1, 1. So W2 plus B should be greater than or equal to 0 and W1 plus B should be greater than or equal to 0. This is if at all you are using a single threshold neuron. So this is, first we have to assume that we are using a single threshold neuron to solve this particular problem, and that single neuron will be having inputs x1, x2, weights w1, w2, and we are telling that we are finding what, and there will be a bias here. So in order that this particular neuron acts as an XOR gate, we want this condition should be satisfied. This condition should be satisfied. So will these conditions be satisfied? Let's see. First of all, first condition says that bias should be less than 0. So the first condition says that bias should be less than 0. Second condition says that W2 plus bias should be greater than or equal to 0. What does this mean? W2 should be greater than or equal to minus bias. So this is what is implied by this statement. Similarly, W1 plus bias should be greater than or equal to 0, which means that W1 should be greater than or equal to minus bias. And last condition says that W1 plus W2 plus bias should be less than 0. So this implies that W1 plus W2 should be less than minus bias. Now is it possible to satisfy these particular conditions? Is it possible to satisfy these particular conditions? How to do it? We shall take an example and check. So assume that, say, we'll take one value of bias, we'll take an example and check if it is possible. Example, we take bias should be less than 0. So we make bias is equal to minus 0.5. So this condition gets satisfied. So what we'll do is that we'll take W1 and W2, both of them we shall take the same value as of now. We shall take them. Now W2 should be greater than minus of bias. So minus of bias will be what? Plus 0.5. So I select W1 greater than 0.5. So I select W1 is equal to 1. This condition is satisfied. So similarly, I take W2 greater than or equal to plus 0.5, because minus bias will be minus or minus plus. So again W2 I also take equal to 1. So this condition is also satisfied. So now if at all I take W1 plus W2, I get 2. Is it less than minus bias? No. So this condition is not getting satisfied. So never it will be possible to get both these conditions, all these conditions satisfied. If at all first condition gets satisfied, second, third may get satisfied, last one may not get satisfied. The last one may get satisfied if at all you select W1 plus W2 is less than minus of bias, meaning if at all you take W1 plus W2 is less than minus bias, meaning I select a value to, this is 0.5. So less than, meaning I take the sum of W1, W2 as say 0.3. So W1 is say 0.15, this is say 0.15. But this, if it happens, then this condition will not get satisfied. This one, W1 has to be greater than or equal to 0.5. So that condition will not get satisfied. So it is not possible to satisfy all these conditions at the same time. So you can write as a conclusion that these 4 conditions which are required from the truth table, which are coming from the truth table, These are the conditions which are coming from the truth table. Conditions cannot, all conditions cannot be satisfied by using a single neuron. So, or I would say that all these conditions cannot be satisfied simultaneously. It is not, if at all you have to use a single neuron, all these conditions have to be satisfied. So all these conditions cannot be satisfied simultaneously. Therefore, single neuron or perceptron cannot be used to solve XOR classification problem. Okay, single neuron cannot be used to solve a classification problem. I will just illustrate one more thing to you all with the help of a diagram. Say this is a single neuron which is considered here, and whatever weights we have considered, say W1 and W2. Let us take the weights which we have considered W1 and W2 or something like that, or if at all any other weights, if at all you, okay fine. I shall just try to draw a line here. If at all I draw this particular line here, and this line, say I will use a different color, somewhere here, and this particular value is say 0,5, and this value here will be 0.5, 0. So what will be the equation of this line? Equation of this line will be x1 upon 0.5 plus x2 upon 0.5 will be equal to 1. So this particular line which is selected, if at all I write it in this particular form, what will be happening? If at all I take 0.5 on the other side, what will happen is that I can write it in this particular form, x1 plus x2 is equal to 0.5. So it will become x1 plus x2 minus 0.5 is equal to 0. So this will be the equation. But this equation, so it is like, if at all I replace here, what looks like x1, w1. So w1 is equal to 1, w2 is equal to 1, and bias is what? Bias is minus 0.5. So this line which is used here cannot be used to solve XOR problem, because one point, that is, okay, this point is classified, this point is classified, these 2 points are also classified, but this point will be misclassified. Is that clear? So if at all we do this particular line, whatever is shown here, if at all we consider this particular line, okay, so by using this particular line, consider this particular line, consider line x1 plus x2 minus 0.5. So this gives rise to w1 is equal to 1, w2 is equal to 1, and bias is equal to minus 0.5. So this is, but by using this, what will happen is that 0, 0 is classified into class 1, then we have 0, 1 and 1, 0 is classified into class 2. So I say that whatever lies this side will be class 2, and whatever lies this side will be class 1. But what is the problem? 1, 1 is misclassified into class 2. 1 comma 1 is actually a point from class, this one, class 1, but it is getting classified into class 2. Is that clear? So what I wanted to show you here, already we have proved that a single threshold logic cannot be used to implement XOR classification problem. But what I wanted to do is that if at all we use a single neuron or perceptron, what happens? This is what happens. That is, one point will get classified, other points will get misclassified. Is that clear? So that is the reason we cannot use this particular thing to classify. A single threshold neuron cannot be used for XOR classification problem. When I say XOR classification problem, same thing holds true for XNOR classification problems. Only thing is that in XNOR, what will happen is that the output will change. What is the XNOR? Say I am doing for XOR. Tomorrow in the exam you would be asked maybe XNOR. XNOR, what is the difference it will be? This will be 1001. So 1001 meaning the classes are changed. This one will become class 2 and this one will become class 1. That's it. So that is the only difference for XNOR. Is that clear? So now next we shall see how to solve this XOR classification problem.